Okay, we can begin, guys. And greetings once again, and welcome to today's session. In today's session, we are going to be looking at this simple problem here, which is based on your exponential functions. And just to confirm, can you guys see my screen? Just give me a thumbs up if you can. Should be able to see my screen. Awesome. Right. So in today's lesson, guys, we are going to be looking at this problem here, which is an exponential function problem. And it requires us to understand inverse functions as part of this problem. So let's go ahead and have a look at what is going on. Okay. So the question reads, or the statement reads, the graph f of x. So one thing I need to just quickly make notes for you is the following. I'll just say remember, because this is something that you need to remember in the future. So that notation there, which they used, all what it means, or what it was meant to mean, is just f of x, okay? Nothing deep. So that was not supposed to confuse you. So what are they saying? They are saying that f of x equals a to the power of x. And they say that it passes through that point, which is 2 and 9/4. Okay? So let's have a look at our first question, which is a. They say calculate the value of a. So remember that our f of x is a to the power of x. And the question is now asking us to calculate a. And how we are going to calculate a, we are going to use a point which we are given. So we need to go and use that point, which is 2 and 9/4. What does this point mean? It means wherever we see x, we can put 2. And wherever we see y, we can go and replace it with 2/9. So let's go ahead and deal with that, because our problem, we know it is just y equals a to the power of x. That is what they told us up here. So this means that wherever we see y, we can go and put in 2/9 equals wherever we see a, we leave it as it is. And then wherever we see x, we can go and put a 2. Okay. But that is 9/4. Not sure where I'm getting the 2. So that is 9 divided by 4. And the y is 9 divided by 4. Okay. And from here, it's very easy, guys. We need to go ahead and solve for a. Okay. So if you remember all, you will see that this is a difference of 2 squares. So if you look carefully at a squared minus 9/4, which is equal to 0. And for some of you, you will be able to see that this is a difference of 2 squares. So you have a squared minus 3/2 all squared equals 0. And how you deal with such a problem is very simple. You open 2 brackets. You'll have a plus 3/2, and then you will have a minus 3/2, and this will be 0. So when you solve, you will see that you'll have a plus 3/2 equals 0, or a minus 3/2 equals 0, which means your solution for a, it is 2 of them. And we'll go ahead and worry about which one is which. So for a, we are getting a solution of 3/2, or a solution of negative 3/2. So someone else from this point here would have just used the square root already. So someone else would have just said, my a will just be plus minus the square root of 9/4, which would have given them plus or minus 3/2. So that is another way of getting the same answer, the same values for a. Okay. Now let's go to the next one. Okay, let's go to B, and we'll worry about which a value we should take later. So for B, they say write down the equation of the inverse in the form of f minus 1 equals that. So now my question maybe for you guys should be, before we move on, which value of A should we take? So which A is correct? Anyone?
The A, I think, should be 3/2.
Why 3/2?
I don't know, maybe because this is the inverse. So if we do the inverse, we can't have the negative log, and if we do the log on the inverse, it would give us the error. So meaning 3/2 is the answer.
Okay. So let's take that. So your comment there is correct. So we'll take A is 3/2. So this will be our answer. For anyone who doesn't understand, you'll see a bit later why the other one will give us a problem. Okay. So let's go ahead with that. So let's go to B. So it means our problem now is just f of x equals 3/2 all to the power of x. And this we can just write as y equals 3 divided by 2 all to the power of x. Okay. And now remember, guys, they are looking for the inverse. So once they introduce this minus 1 at the top, they are referring to the inverse. How do we find the inverse? How we find the inverse is we need to swap x and y and then solve for y after doing the swapping. So we swap x and y and then we solve for y. Very important for you to understand. So let's go to our equation above. You look at our equation, which I'm putting the red star, you can see how it looks. So when we now want the inverse, wherever there was y, I'm going to put x. Wherever there was x, I'm going to put y. So there was y there, I'm putting x. You look carefully, I've switched them. So the y was here, and now I've switched it with the x. Okay, that is what we did. So all what we need to do now is to solve for y. And to solve for y, we will use our logs. So our y here will simply be y equals log. What was the base now becomes the base of the log. So it becomes 3/2. And then we have our x here. Okay, that is what we have. So you guys should make sure that you do remember your log laws. They are very important. So if, for example, we are trying to solve for, let's say, c, and we are given p to the power of c equals d, how we solve for c is we introduce log. This will be the base of log now. So our c will be log, then we'll have the p there, then we'll have the d here. Okay. What is our answer? Well, let's go back to what we were asked. So our answer, which is the inverse, is simply log with base 3/2, and we have our x here. Do you guys have any questions? Do you understand? If yes, give me a thumbs up. And if not, please ask. And that there is the inverse, good people. So we're done with the inverse now. What we need to go and worry about is reflections. So you guys need to remember your fundamentals of reflections. Okay? When they say a function is reflected about the x-axis, what do they mean? The y-axis, what do they mean? So let's go and have a look at our reflections. So we're looking at C now. So if you look at C, C reads, determine the equation of G, of which G is the reflection of F about the y-axis. So what note do I need to make? I need to make a note that we need a reflection about, very importantly,
So you are muted.
check that. Am I now back?
Yes.
Apologies, guys. I think there's someone in the meeting who's muting me. Guys, please, let's be good human beings, okay? Let us not appear like we're working with the devil. Okay, so let's have a look at what is happening. So the blue axis, guys, this is what you call your x-axis. And this will be important because they are saying we should make our reflection to be about the y-axis. So understanding what difference that makes is important. So if I have a function, I need you to think carefully now. If I'm reflecting something about the y-axis, let's say something is like that. If I'm reflecting it like that, what that means is I need to multiply the y by a negative. So change the equation by a negative. So if, for example, I have y equals a to the power of x, for me to have a reflection about the y-axis, which is this one here is a reflection. Okay, that one is about the x-axis, reflection about the x-axis. So look at the difference that it makes on the equation. The equation now just becomes y equals, we make it black, it becomes y equals negative ax. So meaning whenever we are reflecting about the y-axis, guys, do you see what difference we make on the equation when we reflect about the x-axis, sorry. So reflection about the x-axis. So if you look at the difference which we do, all what we do is we multiply everything by negative. Do you guys see that? We multiply the equation by a negative. That is how you change it. So multiply the equation by a negative. Okay, but now let's think about what happens when they say we have a reflection about the y-axis, which is the blue. Now, let me quickly draw a function. So when we reflect about the y-axis, the equation will look like this instead. It will be the pink. So that pink will be the reflection about the y-axis. And how does the equation change? The equation just becomes a to the minus x. What we have done when we reflect about the y-axis, we change the sign of wherever we see x, we put an opposite sign. Okay, let's make a note of that, and then we'll go and execute. So what do I mean? When we do reflection about the y-axis, let's make some space. When we do reflection about the y-axis, what we do is we multiply x by negative. Meaning we just change the signs of the x. Wherever there was a negative, we change it to a positive. So maybe we can just say we can multiply by a negative or change the sign of x. Do you guys understand that? Very important. You do give me a thumbs up. If you don't, please ask. So I told you two things. When we reflect about the y, the x-axis, which is the blue line, we multiply with the negative. We take the equation, we put a negative in front of the equation. That is when we are reflecting about the x-axis. Then when we are reflecting about the y-axis, we focus on where there is x only. Where there is x, we change the sign. So now let's go back to our problem here, guys, which is we are still looking at number C. So they are saying on number C, we must take the reflection of f about the y-axis. So what is the equation of f of x? It was 3 over 2 to the power of x. Now we must find the reflection. And remember, guys, they said the reflection is about the y-axis. So what should I do to this equation? Anyone? To get the reflection.
Yeah, I think if we're about to deal about that, meaning where there is x, we'll put negative. Meaning the graph of the reflection in the y-axis, or the question, or about the meaning will be like h of x is equals to 3 over 2 to the power negative x.
Yep, to the power of negative x. You are a genius. So that is what we needed to change, guys, here. Because whenever we are doing reflection about the y-axis, that is what we change. So that is what happens when we are dealing with reflection about the y-axis. Where there was, you change the sign of the x. If the x was x, we make it minus x. If it was minus x, we make it plus x. Do you guys understand? That is all what you need to do when they say reflection about the y-axis. Easy. Okay, so let me have a look at C. Determine the equation of G, the reflection of F about the y-axis. Okay, done with that, guys. This is our answer here. And if we want, we can simplify this a bit, but I'm not going to go there. There's no need for that. Then let's go to D now. So for D, they say determine the equation. Well, I was doing, this is supposed to be G of x. Then now, if you look carefully for the next question, they say we need to determine the equation of H, which is a reflection of F about the x-axis. What are they saying? We are now dealing with the reflection about x-axis. And we need to remember, guys, the smile, what I said when they say reflection about the x-axis, what I said is that you take whatever equation which was given, you multiply it with a negative. You don't touch the x, you touch the actual equation. So we were given f of x. So our f of x was 3 over 2 to the power of x. Now we want h of x, which is the reflection. What is going to be the equation of the reflection, guys? Anyone?
H of x.
It is going to be what? What is it going to be, guys? I can hear someone is unmuted, but they're not giving us the answer here.
H of x.
Alright, h of x
is equals to negative 3 over 2 to the power of x.
Yep, on point. So thanks for that. We can now mute, guys. It is going to have a negative here in the front. Then we'll have 3 over 2 to the power of x. What is your takeaway, guys? This is the only healthy takeaway, by the way. So your takeaway should be, once they say x-axis and reflection, what you do is you just go and introduce a negative in front of your equation when we are dealing with exponents. Is that clear, guys? If it is, give me a thumbs up. If it is not, please ask a question. Once they say reflection, then x-axis, we put a minus there in front. We multiply by a minus. Once they say, let's go up. Once they say reflection, y-axis, Wherever we see x, we go and put a minus. X-axis minus on the whole thing. Y-axis minus on the x. We change the sign of the x. So this here is our answer. That there becomes our answer for the question D. Do you guys understand? Very easy. Now we just need to go and plot and plot and plot and plot. Let's go to the next page and do our plots. So what are they saying? They are saying that we need to go and plot f, g, and h, and the inverse of f. Okay? So let's go ahead and do that. The first thing I'm going to plot, guys, is f. Let's go ahead. Let's see our plots. So maybe let me take this and put it this side. So I'll quickly write down the equations just for you to remember. So remember that we had f of x, which is 3 over 2 to the power of x. And then we found the inverse, f minus of x, which is log 3 over 2x, done with that. And then if you remember, guys, we then had to go and find g of x, of which the g of x, if you go to the previous page, you'll see it's 3 over 2 to the power of minus x. And then we then find h of x. So we found h of x, which was equal to, I think, minus 3 over 2 to the power of x. So we need to go and plot all of these. Okay. Now what we need to do is we just find the x-intercepts for the original equation. So we need to just find the intercepts and asymptotes of the original equation. So here what we are looking for is intercept and asymptotes. Let's make some space. We are looking for intercepts and asymptotes for the equation that we started with, which was f of x. Okay. So if we look at f of x, guys, the equation is y equals 3 over 2, the power of x. So since we don't see anything here, we always put 0. And we know that our exponential functions, they have a horizontal asymptote. So this here becomes our horizontal asymptote. So that means we have y equals 0. So the y equals 0 means it's a line that we can't touch. And remember, the y equals 0 line is the x-axis. That is where y equals 0. Okay. And then we can go ahead and find the y-intercept. So meaning we can't have the x-intercept. Let's find the y-intercept. And remember, when we are looking for the y-intercept, we always set x to be 0. So which means we have y equals 3 over 2 all to the power of 0. And this just becomes 1. So meaning our y-intercept is at 0 and 1. So let's go ahead and start by plotting the black graph. Okay, maybe let me not make it black so that we can see which one it is. Let's have a look at another color. Let's make it pink. Okay, that is not looking good. Let me quickly rewrite that. So our f of x will be 3 over 2 all to the power of x. So if you look carefully, what we found, guys, was that we have a horizontal asymptote. And that horizontal asymptote is at y equals 0. That is where our horizontal asymptote is. So I'm going to put on the green line here, it's the line we are not supposed to touch. Then let's go and draw our pink graph. So because of the value of a, guys, whenever the value of a, or whatever that sits there, is bigger than 1, how the shape of your graph looks is as follows. How the shape of your graph will look will always be something like this. When that value that we have here is bigger than 1, your graph will look that way. I'll give you a summary at the end. So what this means is that our graph will look something like this. Let's make it bigger. Our graph will look something like that. And then this point here, we already have is at 0 and 1. You guys understand? And this is f of x. You understand? Give me a thumbs up. If you don't, please ask. Okay. I see a hand from Tepang. You can go ahead. What is your question? Okay. I seem not to be able. Yes.
I wanted to ask, do we just put the 0 or do we take it from somewhere?
What do you mean, do we take it somewhere?
Is it the 0 on the point on the pin graph, or?
Which 0 are you talking about? Is it this 0?
Yeah. Is it the one that it is the horizontal?
No. So the horizontal asymptote. So remember that 0 there is for x. The horizontal asymptote is y equals 0. So meaning it's the x-axis. You know that y is 0 on the x-axis. That is why when you find the x-intercept, you make y to be 0. So the 0 there is for x because on the y-intercept, x is 0. You understand? Okay. Awesome. Anyone else? I can see. Okay, I see no question. Then let's go ahead. So let's plot. And remember, guys, it's easier to plot the reflections. So if you remember, the reflection about the y-axis should be something like this. Do you all agree? So I need to figure out which one was the reflection about the y-axis. So the reflection about, no, the x-axis, that was F, that was G. Okay, so G, which is the red one, this is the reflection about the x-axis. So meaning below the x-axis, we must have another graph that looks like the one we have at the top. And that red graph there becomes G of x. That G of x, we know what it is. It's the reflection about the x-axis. So that becomes, wait, what did I say? What is G? Reflection about H is the reflection about the y-axis. Yeah, this should be H here. Reflection about the x-axis. Yes, H. H of x, because look at the original graph. We are reflecting it about the x-axis. So the H graph is the one that was the reflection about the x-axis. So the H graph is the purple one. So let's quickly make sure that our colors are on point. So the purple graph, like that, and that is H of x equals -3/2 all to the power of x. Do you guys understand? Yes, give me a thumbs up. And if no, please ask. It's very important that you understand. So H was the reflection about the x-axis. So that is why below the x-axis, we put another graph now, because that is what H is according to what we determined here on D. Okay. Now let's go and have a look. The reflection about the y-axis, that was G. Okay. So G is the reflection about the y-axis. So where is G? G is the red graph. And we said reflection about the y-axis just means the mirror is the y-axis. That is what it means. So the mirror is the y-axis. Where is the y-axis? Y-axis is here. The reflection about the y-axis means we make the y-axis to be the mirror. If you make it to be a mirror, this is how it should look. And that should be G of x. Do you guys understand? Yes, give me a thumbs up. If no, please ask. So when you say reflect, you are saying create a mirror about the y-axis. So the graph should make sense. G of x is 3 over 2 to the power of minus x. Okay, that is what we have. Let me create some space to just sort this out here. Okay, that is better. So now what is left is the blue graph. Let's go and look carefully. What was the blue graph, which is the F minus? That is the inverse. Now, there's something I need you to remember, guys, about the inverse. We said for the inverse, we swap x and y. What does that mean? For the original graph, which was F, let's use yellow. For the original graph, which was F, it was y equals 0, which was the asymptote. It means for the inverse should not touch x equals 0. Now, you guys understand that? So all what you do, you swap x and y. So let's go ahead and see. So with this one here, obviously, because we are reflecting, you should see that the x will still be 0, the y will be minus 1. Now with the inverse, think about it carefully, guys. With the inverse, if you swap x and y, it means that your y becomes 0, your y becomes 0, and your x becomes 1. And if you think carefully, that point is here. The point is here, which is 1 and 0. So now, how should we draw our graph? We know that our graph should get closer towards the x-axis, but it's not supposed to touch it. So the graph for the inverse will look something like this. It will look like that. It will get closer and closer to the asymptote, but it can't touch the asymptote. And that blue graph there becomes our graph for the inverse. You guys understand? Question if you don't, the thumbs up if you do. So this here becomes our inverse, f minus 1 of x. So how you plot the inverse is you think of the original graph and say, oh, the intercept was at 1 and 0. So for the inverse, we switch the x's, it becomes 0 and 1. Then that is how your inverse will go. Let me try my inverse again so that it looks more proper. Yeah. Okay, that is how our graph should go, guys. Any question? I see I have a hand from Descent.
So I was going to ask, so if they say inverse, does that mean that y should be equals to x or x should be equals to y?
Inverse means x becomes y and y becomes x. It means we switch.
Meaning y is equals to x. Meaning if we want to the inverse, we must say y is equals to x.
No, you must switch them instead of saying y equals x. So where there was x, you replace it with y. Where there was y, you replace it with x. Then you solve for y. Does it make sense?
Yeah, it makes sense.
So we can't say y should be equal to x, because what that means is it sounds confusing mathematically, because it means if y equals x, then you might as well leave y as y. Do you understand my concern there?
Yeah.
Yeah. So rather just say, take y, replace it with x, take x, replace it with y, then solve for y. That is how you're going to find your inverse. I see I have a hand from Isabel. You can go ahead. Okay, no problem. So let's have a look at the last question, guys, which is write down the domain in range of f and g. So let's go ahead and have a look at the domain in the range and see how that goes. So that is what question F. So let me make my graph to be a bit smaller because we've done it already. You guys understand? So let's have a look at for f. I need you guys to give me the domain. This is for f of x. So let's get the domain. So when you look at f of x, which is the pink graph, is it restricted when you look at the x values? Let me use pink again here. Because remember, domain, we are speaking about the possible x values. So we're looking at the domain of f of x. So it is an exponential function. It is not restricted in the x values if you look at that one. So we'll just say x is an element of real numbers, meaning x can be anything and everything it wants to be. Now let's look at the range. And we are looking at the range of f of x. So can the graph, which is pink, not have certain y values because of, let's say, restrictions that we can see on the graph? Anyone? So remember, this y equals 0 is our asymptote. So which values of y can we not have on this graph? The pink one.
Y must be greater than 0.
Yep, you guys are so on point. It's very simple. This graph will not be able to cross the green line because there's an asymptote. So meaning it can't have negative y values, but also it can't touch the y0 line because it is an asymptote. So it means all values of the graph must be above 0. Done. That is for f domain. Then they said we should look for the one of g of x. Let's go ahead and look at g. Where is g? G is the red one. So let's have a look at our red function. Well, yeah, this was very easy. Domain. So let's look at g of x. When you look at g of x there, is it constrained as far as how left and how right can it go? Meaning we're speaking about x values. You guys see any constraint on the graph of g on how far it can go to the left and right?
No.
Answer is no. So it will be x is an element of real numbers. Now let's have a look at the range then. What is the range of this rate function?
Y must be greater than 0.
Yep, y must be greater than 0. It is still subjected to the same asymptote if you look carefully. So before we close, there's someone or there's one question that I want to push to you, which is, let's go to this next page. So I need you guys to help me to figure out the domain for f of the inverse. So what is the domain of this inverse? When you look at this inverse, which x values can't it have?
The negative x values.
Yep, it can't have the negative x values. But remember, we have an asymptote as the yellow line. So meaning it can't have an x value, which is what?
Which is 0.
Which is 0. So meaning all x values must be on the right of 0. And how we write that mathematically is x is greater than 0. And the teacher will be so happy. Let's have a look at the range. What is the range of the inverse? Anyone?
Y is element.
Y is the element of real numbers.
Why? Why is y an element of the real numbers?
Because of there is no asymptote for the y.
Yep, that is correct. So if you look at the graph, our graph can go as up as it wants, the blue one, and it can go as down as it wants. We don't have any restriction to say you can't get here. There's no line that we can see that is stopping us from going up and down. Very important. And then lastly, let's have a look at the purple one. So I need you guys to give me the domain of h of x. What is the domain of h of x?
X must be less than 0.
Numbers.
Yep, x will be an element of the real. Then let's have a look at the range of our h of x. What is it?
Y must be less than 0.
Why must y be less than 0?
Because there are no asymptotes for the Y values.
Hmm? Give that a shot again. You are saying y must be less than 0 because
It must not go to the positive Y values, the graph.
yeah. So if you look at the graph, and it's very simple when you explain things looking at the graph. So what the graph tells you is that at y is 0, which is the green line, we can't touch it. But if you look at the y values, the graph goes down and down. So meaning it can go as low as it wants. But as far as going up, it can go up, but it can't touch the 0 line, which is the green. So that is why we're saying the graph has y values which are all less than 0, meaning it can go down as it wants. And that is how we came to that answer. So this, guys, concludes our lesson. Do we have anyone who didn't understand what we did here? And if you understood and you are happy, please give me a thumbs up. Very simple, isn't it? Inverses. So you guys should make sure that you practice and you master these. They are very simple. When they say reflection about the x-axis, you must know what to do. Reflection about the y-axis, you must know what to do. Very easy. You guys will pass this. If there's no further question, we can end here.